Hi, I'm Miss Hearn. Let's get started. Now I want to talk about something that's totally new probably to most of you. So if your brain takes a little while to start absorbing the notation, be patient with your brain. It's normal for that to happen. But the motivation for what we call logarithms, this new thing, is we can't solve all exponential equations by rewriting both sides with the same base. 5 to the x equals 25. Yeah, 5 to the x equals 5 squared, in other words. So, well, clearly x must be 2. So we got that one. But unfortunately, 60 is not a power of 5, so we can't solve that one. We're stuck. So the way that we approach this is we introduce a new notation called a log. We're going to take a step back now and look at an old notation that you're already familiar with and make a comparison. We've previously learned about exponential form, exponents. We learned that, for example, 2 to the third is equal to 8. We call 2 the base, or 5 squared equals 25. 5 is the base. In algebra, we have what are called fact family. For example, 2 times 4 is equal to 8 is related to 8 divided by 2 equals 4. These are part of the same fact family. It's a different relationship between the same three numbers. When it comes to exponents, you had some fact families as well. You might not have thought of it that way, but if you change this to radical notation, notice that we still have the 3, the 8, and the 2 when we say the cubed root of 8 is equal to 2. Why did we introduce this radical notation? Because sometimes we're missing the base. And we say, okay, well, what number do you raise to the third power to get 8? And in order to ask that question, we use this radical notation. Or square root of 25, even though the index isn't written, it's assumed to be 2. What we're really thinking when we take the square root of 25 is, what do you raise to the second power? What do you square to get 25? Well, today we're going to use this new log notation. And what it's going to help us do is to ask a question not about the missing base, but if the power is missing, as it is in those equations we want to solve. So when you see log base 2 of 8, all that's asking you to do is to think 2 to what power gives me 8. This time the power is missing. It's still all the same three numbers. These are equivalent. But when the power is missing, we write it as log base 2 of 8. What power do you raise 2 to get 8? The third power. Log base 5 of 25, you're thinking, what power do you raise 5 to get 25? The second power. Okay, and you see that 5 squared equals 25 and log base 5 of 25 equals 2 are related to each other. They mean the same thing. It's a fact family. For example, log base 3 of 9. The question that's asking is base 3 to what power results in a 9? We're always looking for the power when we're finding a log. So what's the answer to that? 2. And the reason why is because 3 squared is equal to 9, right? All right, how about log base 4 of 4 means base 4 to what power results in 4? 4 to the first is 4, so the answer is 1, the exponent. Here's an interesting one. Log base 5 of 1. Base 5 to what power results in a 1? Anything to the 0 power, remember, gives us 1. So the answer is log base 5 of 1 is 0. How about log of 10,000?
4.
Very good. 10 to the power of 4 is equal to 10,000. The number of zeros, right? So that's going to be a 4. Okay, here's a weird one because you get a smaller number. Log base 9 of 3. Base 9 to what power would give you 3? A square root. Yeah? Very good. So 9 to the 1/2 power equals 3. So that means log base 9 of 3 is 1/2. Log base 3 of 1/3. So that's saying base 3 to what power results in 1/3? 3 to what power gives you 1/3? Remember, when you get the reciprocal, it's because the power is -1. So 3 to the -1 power gives you 1/3. All right, now here's another weird one with that base e. Base e comes up a lot because it comes up in applications a lot. When you come across base e, just take it one step at a time. Remember, natural log means log base e of e to the fifth. So what it's asking you is to take the base e to what power to get e to the fifth? 5, yes. It's like so obvious it makes you doubt yourself, right? So e to what power equals e to the fifth? The fifth power. So that's how we evaluate logarithmic expressions. I hope you found this video useful. If you did, please remember to like it.